Good afternoon, class, and today we'll be learning about projectile motion. Now, our objectives in this PowerPoint are to define what a projectile is, describe how a projectile moves along the x and y axis, as we'll be talking about later, and to calculate and solve basic problems dealing with projectile motion with the basic equations. Now, what exactly is a projectile? A projectile is an object where the only force being applied to it is the force of gravity. If an object has any other force other than gravity acting upon it, it is not a projectile. Now, many students have trouble grasping onto this idea that the only force acting upon it is gravity, such as if I throw a rock up in the air, there has to be a force causing that rock to go up into the air, but this is not true. This is because Newton's law suggests that a force only makes that object the force keeps it in the force does not keep it in motion, it just causes an acceleration, and thus this is the reason mass is not considered in the problem solving of a projectile, because the only force acting upon it is gravity. Now, the projectile could be any size of it can be any object size. It could be a golf ball, football, it doesn't matter. And in a projectile problem, you can solve for x or y velocity, the time, or the displacement traveled in the x or y direction. Next, you have the different types of projectile motion. First, you have horizontal motion, motion of an object rolling freely on a level surface. Horizontal velocity is always constant. As you can see in the bottom right picture, the cannonball is shooting a cannon from the top of the cliff. And as you can see, the horizontal velocity is always constant, 20 meters a second. And as you can tell, the vertical component of the velocity is increasing as it goes down, because it's accelerating at a constant acceleration of negative 9.8 meters a second. Now, the other type of projectile motion is vertical motion, free-falling object where the force is due to gravity. Vertical component of the velocity changes with time. As you can see, it's the picture on the bottom left of the man dropping the ball down to the cliff and the man dropping the ball up and down. In this, the vertical component of the velocity changes with time, and the acceleration of this projectile is again negative 9.8 meters a second. And in the third type of projectile motion, you have a parabolic motion, path traced by an object accelerating only in a vertical direction while moving at a constant horizontal velocity. And that is the third part of the bottom left picture. Projectile motion is a free-falling projectile that has a horizontal component to the path of motion traveled. It is independent of motion, meaning it has no other force acting upon it but gravity, and air resistance is negligible. Time is constant in the x and y direction, and the x velocity is constant. Acceleration is always, again, negative 9.8 meters a second squared. Here we have the y equations, or the equations used to solve for the vertical velocity or the vertical displacement. And these equations are also used to solve for the acceleration and time. Here in these equations, you have VO, which is the initial velocity, VF, which stands for the final velocity, A for acceleration, and T for time. Here we have the x set of equations. The x component, the main equation, is velocity equals delta x over time. This equation is used to solve for the velocity in the x direction, the displacement in the x direction, and the overall time. And thank you very much.